Okay, so good evening. In this video, we'll be seeing the solutions to the grant test which was conducted a few days ago. So the grant test had a total of 12 questions for 60 marks, and the duration of the exam was 90 questions. Now the syllabus of the exam was all the syllabus completed on both Tuesday and Friday classes. Let us go through all questions one by one. So the first question: if x is equal to root of 5 plus root 21 and y is equal to root 3.5 minus, this is supposed to be root 1.5. I think everyone understood that. Find the value of x plus y whole square minus 4x. The first and foremost, x plus y whole square minus 4x is nothing but x minus 5 whole square. So basically, we need to find the value of x minus 5. Okay. How to do that? You see, the entire trick lies here. If x is root 5 plus 21, the most important thing we have to see is 21 is nothing but root 7 into root 3. Now root 7 into root 3, this can be expressed as 7 plus 3 by 2. Therefore, in total this can be written as 1 by root 2 times r. Root 2 times root 2 is multiplied and divided. This is nothing but root 7 by 2 plus root 3 by 2. Now, some of you must be wondering how we came to that. So if you observe this carefully now, 10 can be written as this is nothing but 1 by root 2 times root 7 square plus root 3 square plus 2 times of root 7 root 3, which means it is in the form of a plus b whole square. So that means finally x can be written as root 7 plus root 3 whole square, and the square root is cancelled, and in the denominator you have root 2 root 3. Now if you observe carefully, whatever you're getting over here in x, you're getting root 7 by root 2 plus root 3 by root 2. The same thing you have over here. This, because this is nothing but root of 7 by 2, and this is also root of 3 by 2. Correct? This can be written as 7 by 2, and this can be written as 3 by 2. But there's a minus sign over here. So here you have a plus sign, and here you have a minus sign. So when you subtract both of the terms, this is your y, this is your x. We got x as root 7 by 2. Y is root 7 by 2 minus root 3 by 2. Therefore, x minus 5 will give you 2 times of root 7 by root 2 or root 14. Therefore, x minus 5 whole square will be 14. Let me just do it on the whiteboard. So, x is equal to the important step over here is to multiply and divide by 2. Multiplying and dividing by 2 gives us, which gives us this critical step here. The root 7 square plus root 3 square plus 2 times of root of 7 by 2. Therefore, this will be equal to 7 by 2 plus root 3 by 2. And similarly, y is given as root 7 by 2 minus root 3 by 2. From here, we can tell x minus 5 is equal to 2 times of root 7 by 2. Minus 5 whole square will be equal to. That's the first question. Right. Now the second question. Second question saying this is you have to solve this equation which consists of greatest integer function. the HC or I think everyone understood that. Any second question. Now the problem is in second question you can find x, but you can actually find it only to see to tell two significant digits. Will tell what I mean. That means it is given x plus 0.19 x plus 0.2 plus x plus 0.91 is equal to 546. Now, if you count the number of terms 1, 2, so 91 to 19, we'll find out that there are 73 terms in total. Since this is an integer function, that means the output should be some integer. Now, if you assume that all of them are giving an output of some integer I, let us just assume for the moment that all of them are giving the same output I. Then that means that 73 times of that output I should be equal to 546. But if you just solve this, then you'll see that I is not actually an integer. It will turn out to be 7 point something something. This is not possible because I should be a perfect integer. Correct? That means it is not. That means our assumption that all the output will be I is wrong. What does it mean? I'll show you a small example before I solve this question. Suppose let us say I have one more series which goes like let us say I have a 6.85 plus 0.05. This is the first one. Let us say second term is 6.85 plus 0.10. 0.1. 6.85 plus 0.15. 6.85. Now we are dealing with something very similar. You see what is happening here. The output of this is 6 because this is 0.69. Sorry, 6.9. The output of this will also be 6. But the output of this term will be 7. Correct? Because this will be exactly 7. And the output over here will also be 7. So on and so on. That means here, even though the same thing is being repeated, since the fractional part in one case, the fractional part is such that the sum of both these fractional part has become an integer 1. Therefore, the integral part has also changed from 6 to the next integer. Now, if this example is clear, something very similar is happening in this question too. What is happening? We are assuming that the output is I, but somewhere down the line, since the fractional part is constantly increasing, somewhere the output will change from I to I plus 1. Now let us say the first n numbers are giving an output of I. Out of the 73, let us say first n numbers are giving an output of I. Then we can write this as n times of I. Then the remaining 73 minus n terms will give an output of I plus 1. And adding both of them, we have to get 5.6. Now, what is the value of I? Now that is clearly understood. The value of I has to be 7, correct? Because it cannot be something greater, it cannot be something small. If you take I as 8, then this will exceed the value of 546. And you cannot take something smaller either. So I has to be 7 and I plus 1 will be. That means 7 times of n plus 73 minus n times of 8 has to be equal to 5. From here you get that the value of n is equal to I mean the first 38 terms are giving an output of 7 and then the next remaining terms are giving an output of 8. Someone might question, sir, how do you know that the remaining terms are giving an output of 8? Why not more than 8? No, that is not possible because the common difference is 0.01 and you have lesser than 100 terms. So it is not possible that it takes it takes the next integer also. Now, if the first 38 terms alone are giving 7, then we need to find the 39th term. The 39th term onwards should be almost a perfect integer. Why am I saying almost perfect? I'll explain later. So the 39th term will be x plus 0.19 n minus 1. 39 minus 1. The common difference is 0.01. Which should turn out to be x plus 0.5. Now this x plus 0.57, the fractional part of x and 0.57, both of them should add up to become 1, which means the fractional part of x should be 0.43 and some other negligible digits. Right? Now, from here we already saw that the integer part of x is 7. Here the fractional part is close to 0.43. Therefore, the solution for this is x is equal to 7. Now, this is a question where you have to sit down, think for some time. You might have to watch this solution one more time. I'm sure some of you might be wondering, sir, why exactly did you take I as 7 or why are you writing 0.4? But it's not difficult to understand. Just sit down and think for some time. Next, third question. Find the number of zeros at the end of 2021 factorial. So I'll explain in the class. So you can find the number of zeros at the end just by finding the exponent of 10. Now most of you got this right in the exam, but the problem is many of you applied the method rather without desecration, in the sense that many of you in the exam you try to do this step of 2021 by square. This is actually wrong because this method which was taught in class was this method which I taught in class is only for prime numbers. That method is only for prime numbers. Now, how to find the exponent of 10? Now, 10 is not a prime number, but 10 can further be prime factorized as 2 into 5. That means if I find the exponents of 2 and 5, will that be sufficient? Yes, that will be sufficient. And to be more specific, out of 2 and 5, it is obvious that the exponent of 5 will be much lesser because most of the terms, other terms will also have 2. But if I find the exponent of 5, then that would give me the number of zeros also. Correct? Someone has a doubt. For example, let us take a simple example. Let us take we have to take an example. Let's go ahead. Let us find the number of zeros at the end of 10 factorial. Now 10 factorial. Now how to find the exponent of 2 at the end of 10 factorial? That would be 10 by 2, step of 10 by 2, step of 10 by 4, step of 10 by 8, which is 5 plus 2 plus exponent of 5 will be step of 10 by 8. That's it, which means it is 2. That means 10 factorial can be written as 2 power 8 into 3 power something, but then 5 power, I don't know the 3 power yet, but it is 5 power. That means it is How many tens can you form here? If you borrow two from A, this becomes 2 power 6 into 3 power something. 5 into 4 whole square. That means you're getting a 10 square term over here. Since you are 10 square, that means you're multiplying this entire number with 100, meaning that you will get two zeros at it. Therefore, at the end of 10 factorial, you will have two zeros. Now, all of you can verify that. Online also you can verify. For example, 10 factorial. Let's see if I get it directly. Yeah, so 10 factorial is 3628800. So that's the same thing. Now over here, to find the exponent of number of zeros at the end of 2021 factorial, also we need to implement the same method. We need to find the exponent of 5. So the correct approach to do this question is 202155 plus 2021 by 25 plus 2021 by 125 plus 625. No, 625 to 5 would exceed 20. So that's it. To start simplifying these values, so first of all, this will be 20 You understand what I'm doing, right? I did this, now I'm dividing this by 5. Now I'm dividing this by 5 and get this. That's what I did. Divide this by 5 and get this. So, so the answer will be 484 plus 60, 500 plus 500. So this will be the answer. You have 503 zeros at the end of 2021. Okay, so next question. Question number 4. If two vertices of a square lie on a circle, radius r, and the other two vertices lie on a tangent to the circle, find the length of the sides of the square in terms of r. Okay. So some of you used many wild methods to do this question, but it's a simple question to be honest. You have a square, and you have a circle. You mentioned that the circle has to be constructed something. Yeah. So we have a diagram, something like this. Two vertices are on the circle and two vertices lie on the tangent. So this is what it will look like. So find the radius in terms of, or find the length of the square in terms of the radius. So let us say this is some A. This is a center. This is R. This will be A by 2. No, no. A by 2. We need to be clear. This is the center of the circle. Yeah, correct. It's the center of the circle. It's not the center of the square. So, in that case, this is capital R. This will also be capital R. This in that case, since the whole thing is here, this will be A. If this whole thing is here, this thing will be A. That's it. Now you have a right angle triangle with R as the hypotenuse, A minus R, and A by 2 as the length and breadth. Now applying Pythagoras theorem, you can get the answer. That's simple. So a by 2 whole square plus a minus r square equal to r square, which equal to b square by 4 plus a square minus 2ar plus r square is equal to r square, which equals 5a square by 4 is equal to 2ar, and r is equal to 5a by or a is equal to 8r. The fourth question. Fifth question also is something which looks very tough, but it is actually one of the easier questions. But I know most of the students did not attempt it because it looks tough, but it's not actually tough. Let f of r be equal to sigma n equal to 1 to r n factor. Now something should be assumed or assumed with little intelligence when I'm saying f of r equal to sigma n equal to 1 to r. That means r is an integer. That should be understood because you can apply factorial and sigma function only to integers. F of r equal to sigma n equal to 1 to r n factorial. Okay. So what does it mean? For example, f of 2. What is f of 2? F of 2 is sigma 1 to 2 n equal to 1 to 2 n factorial. What does it mean? That means 1 factorial plus 2 factorial. That's it. If I say f of 3, that means 1 factorial plus 2 factorial plus 3 factorial. That is the meaning of f of 3. So similarly, what is f of r? F of r would mean 1 factorial plus 2 factorial. That is what till r factorial. Now they want you to find the solution set of x. What is x? This is x. Where f of r congruence x mod x. Okay. Let's see what. They want you to find the solution such that x is a perfect square. X should be a perfect square. Fifth question. It should be a perfect square. What is x? X is f of r. X. Now see, since most of the children are not very comfortable or familiar with this, the high chance that students must have. But I explained this many times. It's quite simple. What does this mean? Dividend minus. I'm sorry. This means this is the remainder. This is the divisor. This is the dividend. Right? So this is the reminder. When you divide this with this is the remainder. Or in other words, f of r minus x is divisible by 10. That is what it means. Now, see, this is a since this number is 10, it is all the more easy. Why? Because what is a reminder when you divide something with 10? For example, 273 divided by 10. What is the reminder? The last digit. So that means when you divide something with 10, we are talking about the last digit as a reminder. Right? Now is telling find the solutions of x such that find the solutions of r such that x should be a perfect square. What is x? X is a reminder when divided by 10. What is a reminder when you divide by 10? Basically last digit. But to find all the values of r such that the last digit of f of r should be a perfect square because x represents a large digit. The last digit of f of r should be a perfect square. Now, what is f of r? F of r, as I said, is 1 factorial plus 2 factorial dot 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 till r factorial. Now, how is it possible that the large digit can be a perfect square? For that, you just need to see a few values. For example, f of 1, 1 factorial. Yes, this is a solution. F of 2, 1 factorial plus 2 factorial, which is equal to 3. No, this is not a solution. F of 3, 1 factorial plus 2 factorial plus 3 factorial. 3 plus 3, sorry, 3 plus 9 equals f of 4. this would be f of 3 plus 4 factorial, correct? So this would be 24 plus 2. This won't satisfy. Now f of phi onwards, it's very interesting. See, f of phi is nothing but, let me just write the value of this. 9 plus 24 would be 34. Yeah. So here onwards, 33 plus 128. See, the point is after this is 5 factorial, by the way. After this, all the numbers, all the factorials are going to have 0 at the end, which means the last digit is always going to remain 3 from here onwards. And as long as the last digit is 3, we know that 3 is not a perfect square. So you'll never ever get a solution. Therefore, this only has two solutions, which is r equal to 1 and r equal to 2. Therefore, the solution set of this will be r equal to 1. That's the fifth question. Sixth question. Sixth question is asking if x is equal to 2 plus root 3, then find the value of this expression. We have x cubed minus 7x squared plus 13x minus 2. The question over here. If x is equal to 2 plus root 3, find the value of x cubed minus 7x squared plus 13x. Okay. So most of the students tried substituting it, but I think many of you must have realized that it's not a good idea to substitute. But there is another approach. There are a few approaches. I'll be doing this question with one particular approach. Here, x minus 2 can be written as root 3. If you square and both sides, you get x squared minus 4x plus 4 is equal to 3, which means x cube minus 4x plus, sorry, x square minus 4x plus 1 will be equal to 0. By making use of this equation, this can actually be simplified. How? Observe very carefully. If I divide this entire cubic equation with this, what will I get? X squared minus 4x plus 1. Divide this entire equation with this. 7x squared plus 13x minus 2. What will I get? X cube plus 4x squared plus x subtract minus 3x squared plus 12 minus 12. So become minus 3. Yeah, so subtract minus 1. That's important. What does that mean? That means the answer is actually minus 9. Now, some of you might be wondering what just happened. You see, this is that means this expression x cubed minus 7x squared plus 13x minus 12. Actually, this is the power of reminder theorem. This is actually the technique being used is reminder theorem. How I implemented that? I divided this with the expression x square minus 4x plus 1. Now what happened? That means I got the quotient as x minus 3 and the remainder as minus 9. What does it mean? That means this entire thing can be rewritten as, remember, divisor is equal to dividend into quotient plus remainder. That means this can be written as x square minus 4x plus 1 into x minus 3 divisor equal to dividend into quotient plus remainder. So the whole thing can be rewritten in this format. Now, why is that important? Because we know that this is equal to 0 from the question. If that is equal to 0, then this entire term becomes 0. Therefore, this will be equal to minus. So this completes part 1 of the solutions. I'll make one more video for the second part of it. Thank you.